Okay. So we have this example with two different slope triangles written on one graph. We discussed that the hypotenuse is being shared by this one line, so the slope is equal on both of them. If I were to label the rise here as A and the run as B, and this rise as X and this run as Y, then the statement A to B is equal to what? X to Y. Because A is the rise and B is the run, and X is the rise and Y is the run. So rise over run is equal to the other rise over the other run. What if I were to say A is to X? What would have to be the other side of that statement? B is to Y. So if I'm doing the rise is to the other rise, then I have to do the run is to the other run. Okay, let's put some numbers to this. So instead of A and B, let's make this 4 and 8. And instead of X and Y, let's make this 2 and 4. Okay? 4 is to 8 as what? 2 is to 4. Is 4 over 8 equivalent to 2 over 4? Yes, they're both equal to what? 1/2. Okay, and so 4 is to 2 as 8 is to 4. Are those equivalent? Yes. And they're both equal to what? Not 1/2. 2. They're both equal to 2. So we do know that these statements are true because it checks out whenever we put values to it. These are similar triangles because you can take 2 and 4 and multiply them by what number to get 4 and 8? 2. Also, if you were to divide them, 2 divided by 4 and 4 divided by 8, you would get the same number both times. So that's how you can check to make sure that they are proportional or similar triangles. Okay, let's look at another example. You're going to be given examples that look like this, where you have one right triangle with an added line segment that adds in a smaller right triangle. Do you see the two right triangles? They're just overlapping each other, right? Okay. Let's say that this is A, B, and C for this large triangle that we see here. I'll bold it with blue. And then we have lowercase a, lowercase b, and lowercase c here. What is the corresponding for uppercase A? Lowercase a. They're the same line, they're similar line segments, right? And so uppercase B is to lowercase b as uppercase C is to lowercase c. So if I say A is to C, what should that be equal to? Lowercase a is to lowercase c. Because it's vertical to the hypotenuse, and then the vertical to the other hypotenuse, right?
Yeah. So what if you do uppercase B and lowercase a?
So uppercase b to lowercase a. Okay, so we said this b to this a.
Mm-hmm. So that'd be lowercase b to uppercase a?
lowercase b to uppercase a.
The rough way.
Is that going to give you the same number
Yes.
if they're proportional?
No. Oh, yeah.
You're going to have a big over a small and then a small over a big. Is that going to make sense? No. So this one's not going to be true. Okay. Let's look at another triangle that is overlapping like that, but instead of using just the entire side length, let's use the vertices. The vertices is just the corners where the edges meet. Okay, so this is point A, this is point B, this is point C, and I'm going to make a small triangle inside of it. And that's point E, and that's point D, or yeah, ED. Okay. Side length AB is to side length AC as what? As ED is to what? Here's AC. So it has to be EC. Do you guys see that relationship? Okay, what if I tell you that CD is to CA?
That'll be...
Hold on. CD is to CE.
That'll be DA.
So CD is what? Is to CB.
Or DB.
CD is the same as CB. It's right, people, because if you think about CD, you can CB radio.
And CE is to what? So the first statement, CD to CE, is this one. CD to CE. And then we have, so that has to be proportional to CB to CA. Okay, let's look at another graph. What type of slope is this? A negative slope. I'm going to put two slope triangles on here. We have ABC and JKL. All right, tell me if this statement is true or false. AB is to BC as KL is to JK.
Negative. No.
Corey says false. Why?
No, I say false, but you see, we go from A to B to B to C, right? Then it goes from JK to K to L.
Yeah, because it's correct, but it's just flipped.
Okay, so he said it's A to B, vertical to horizontal. And then this one does horizontal on top and vertical on bottom. Is that the same order?
No.
No, so this one's false. If you were to flip these upside down, then it would be correct.
Yes. Can you write another?
Yep. All right, let's do another practice problem. Is AB to JK as BC is to KL?
Yes, true.
How do you know?
Because AB is down, hold on, AB is up and down, and JK is up and down.
Okay.
BC is side to side, KL is side to side.
BC, KL. Very good. We have the big vertical to the small vertical and the big horizontal to the small horizontal. Very good. So this one is true. All right. Here's another one. CB is to AB as KL is to JK. Take a close look at it. It is true. Some people try to say false at first because we're tracing the line in a different direction, but it doesn't matter what direction the line is. It matters about the line segment itself, right? So this is CB. That's horizontal to vertical. And then KL is horizontal to vertical. So it still works.